Now I am going to start my magnetic generator. This generator is running by a very small 3.7 volt battery, 1.2 ampere, and this is my capacitor bank as I told you, and these are the two coils with the magnetic generator. The main concept is here is the pulse in the coil frequently as done in the motorbikes. Now in motorbikes, ignition coil is pulsed. In older days platinums and these days CDI unit. Now when the coil is pulsed frequently, there is high voltage. That is how the plug is sparked. You can spark the plug in motorbike with a very huge voltage but no ampere. What I did is I connected the outputs of these coils. These coils are also frequently pulsed as in the motorbikes, but here there is the magnet rotor here. It is the rotor is rotated by this magnet sensor here. Yes, a sensor. The sensor, and this is the driving circuit with transistors. So the coils are frequently pulsed here in a very high speed. My rotor is speeding very highly as in motorbikes. The main input power is by this 3.7 volt battery only, right? Now as in motorbikes, please think these are the ignition coils, right? And this is the platinum here. The main concept is the same as the motorbikes. Now this is rotated. Coil is switched on, switched off, switched on, switched off very frequently. Then there is a very high voltage. I rectified this to the high voltage is AC. I rectified to DC. Here is the bridge rectifier. These are rectifiers, two coils. Then I connected the output to this capacitor bank here. Then I was able to get a very good high voltage with good ampere. But earlier in motorbikes, there is a high voltage to spark the plug, but no ampere here. But here I have got ampere. That is my new invention. And initially, now this is my voltmeter. You can see only 1.1 or 1.2 volts in this capacitor bank. Right now, I am going to start this magnet rotor, this magnetic battery. I have to give a small push here. Now I connect the battery. Now I connect very small push here. Now I connect the battery. Now I connect the battery. Okay, now I connect the battery. Right, now it is starting. Now it is starting. My rotor. Now it is speeding very highly as you can see, speeding very highly as done in the motorbikes. In motorbikes, when the flywheel is spinning like this, platinum is connected to that, and the ignition coil is pulsed very frequently. Now these coils are pulsed here. Power is on, power off, power on, power off. Then the spikes, as I told you, these are the AC current comes here and the DC here. I connected it with capacitor bank. Now we can see around 16 volts now. It's rising. Now, as I told you, I run this generator by this 3.7 volt battery. But now, what is the output here is the rising 17 volts, 17.5, 17.6, 17.6. It is rising. But it has this very high voltage than the input. Also, I have much ampere because there are so many capacitors here. Here I have around 30 to 35 capacitor here. Now what is the ampere is very good. This is the 12 volt. This is a 12 volt motor. This is a 12 volt motor. I connected this, and it runs very good, and I can't stop it. That's high torque. That means good ampere. Now I also create. This is the driving circuit for this coils, and this is here you can see. I also created a 555 timer circuit to trigger this capacitor output to the load. Here the indicator indicates when the LED is on it is connected to the load. When off, disconnected. That's the correct way. And I can charge a 12-volt battery using this rotor. This 3.7. This rotor, this my magnet rotor takes only 50 milliamperes to run. Right now, but here I can charge 12-volt car battery using this. In one battery charge, I can run this generator for all the day, around 20 hours. Now it is, I think it is very efficient, and I am doing some improvement day by day in the weekend. Right? Okay. Thanks for watching. I am Tamal Lindiga from Sri Lanka.